Okay, so evaluate factorials. Okay, again, you could do this in the calculator. I mean, unless we make a non-calculator portion of the test. But in the end, if you do, you got to be careful. Like on this problem here, you would need to have this, all of that in parentheses, or else you're not going to get the correct answer. So if you're going to be a slave to your calculator, you've got to know your calculator. Normally, the way we would simplify something like this is like this. The 8 factorial, we know, means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or another way to say that is 8 times 7 times 6 factorial. And let the 6 factorial take care of everything after that, right? So if we write it like 8 times 7 times 6 factorial, now we have a 6 factorial in the denominator, so we're going to be able to cancel that whole thing, right? Now, the 2 factorial we still have to deal with. That's 2 times 1. But by splitting off the first couple factors, I've got something I can cancel with the highest factorial in the opposite side of the fraction, right? So this 6 factorial cancel. So you have to do 8 times 7 divided by 2. Or you could even, like, 2 goes into 8 4 times. 4 times 7 is 28. Okay. Okay, so on the next one, similar kind of thing. We would try to peel off a factor on one side of the fraction so that we could cancel the most on the other side. Notice there's going to be a couple things to do here, like which should I peel off a factor of in the numerator? The 6, right? I got 6 factorial, but there's a 5 factorial on the other side. So let's write it as 6 times 5 factorial. And that will allow us to cancel 5 factorials. But we also have the 2 and the 3. So what should I do there? Yep. So this 3 factorial in the denominator now becomes 3 times 2 factorial. And in the numerator, I still have 2 factorial. So I did that twice, right? I peel off the... So now the 5 factorials cancel, the 2 factorials cancel, and what's left? 6 over 3, which is 2. Okay, now what you can't plug into the calculator is something like letter C, right, because it doesn't have numbers. But you got to think again, which is the bigger, n factorial or n minus 1 factorial? N is bigger than n minus 1, right? So if I was going to peel off some of the initial factors, right, so that I would cancel something on the other side of the fraction, I would actually want to do it with the n, right? N factorial equals n times n minus 1 times n minus 2 all the way down to 1. So it's n times n minus 1 factorial. You know, just take that first factor of n off, and we'll let n minus 1 factorial take care of everything else. Now, on the other side of the fraction, you still have n minus 1 factorial. But now you can cancel them. Same thing in the numerator and denominator, cancel. So the answer is n.
So wait, if you were going to take the n factorial all the way to 1, what would the minus stop at? Like,
what's that?
Like if you were going to, like you said, it would be like n minus 1, n minus 2, all the way up to 1. Where, like, what value would n minus what number would be right before 1?
Well, you don't know what n is. How could you tell? If you don't know what n is, how could you tell?